demonstration of of the AdVoTech2000 voice enunciator. Along with the tape, we've sent along a worksheet that will help you follow along. And if you have any questions as you're viewing the tape, please feel free to jot those down and go ahead and give us a call. Today we're going to be talking about a number of things. First, the applications of voice enunciation, places where we have the unit involved and what our customers are using the product for. Second, we're going to be talking about the actual hardware within the machine. Third, the concept behind the AdVoTech2000. And we're actually going to set off a couple of alarms and make some inquiries into the machine. And then finally, we're going to spend a little time on configuration to show how easy it is to get voice messages into the machine. At that time, in the back of your worksheet, we'll actually have a couple forms there that will show you the configuration screens that I'll be working on the PC over here. Now we have a number of different applications of the technology, and we call this device a voice enunciator. The reason being is it does act as an enunciator and will call out an alarm with a digitized human voice to let someone know exactly where a problem is and what the problem is. Customers have largely used this to increase both operator and technician productivity along the plant floor. Previous to using voice enunciation, they relied upon alarming screens of the DCS system or standard light enunciators. And the operator, if he was responsible for looking at the alarm screen and then going and fixing the problem, there were could be quite a bit of time wasted between when that person goes out and actually fixes the upset. Alternatively, in a number of installations, you will have operators or technicians. They'll actually be out on the plant floor whenever there is an alarm, a bell or a whistle will go off, and they have to go figure out what the problem is. A number of our customers have found, in a lot of instances, the operator was already walking by the problem. So we've had a number of customers, they have reported anywhere from a 20 to 25% increase in productivity with their plant personnel, maintenance people. Particularly with different types of what I'll call line operations, bottling, capping, rolling steel, any type of operation where you have to get a technician or a maintenance person to an upset condition to fix it before you lose production. The second application of the machine is hazardous alarm enunciation. There's no limitation on voice vocabulary, or for that matter language on the AdVoTech2000. So we can be very, very specific as to where a process upset is and perhaps what type of safety equipment to bring in order to fix the upset. So my alarm message could be, please stand by, an alarm has occurred. I have a gas leak at the northwest corner of the plant. Please bring the appropriate equipment. The operator now knows exactly where that gas leak is, what equipment he should bring, and if you would like, you could put information into that voice message which details where that leak is coming from and what corrective action that operator should take. Third, we have something on the machine, we call it the no message option to our different digital points. And this allows us just to say a message with no digital status, or we'll see later, analog process value appended at the end of the message, so we can just say something. A number of our customers have used this feature of the machine to step their operators through either safety interlock with your startup, putting a little bit of heuristic artificial intelligence within the PLC. And we have an example, an alarm of that, or an instruction of that type of batch instruction that will show whenever we're setting alarms off. And finally, the reason why the machine was invented was that it has the capability to call locally over a PA system or a radio system. We'll talk about this when we talk about the hardware. But set on remote, or alternatively by alarm type, if it is critical, it will automatically switch to remote. We'll call out on a telephone to let someone know where and what a problem is, or page them on a pager so they can call back into the machine and inquire on it and see what the problem is. A number of different remote locations, and then we now can have a situation where the engineer can query the plant to find out exactly what the problem is, maintenance people can also do that, so that they're equipped with the correct parts, tools, etc. before they come to fix the equipment. A number of our customers have reported a 50% decrease in maintenance call-out, simply because whenever the maintenance personnel are making the trip, they only have to make one trip now that they're fully equipped. So that's pretty much a number of the applications of the technology, although we're getting more and more each day. I want to talk a little bit about the hardware I have here, and then actually some of the hardware in the machine. We have a printer here. This is my actual the demonstration unit that we take out on the road. Our different distributors and manufacturers reps have. And we'll talk a little bit later how the machine is connected. For demonstration purposes, we've just taken the machine and hardware. It's a little bit of direct I/O here. A telephone that we use is a speaker phone. In this demonstration, you get the voice out. And this is our video terminal option. There's a PC sitting over here. We'll use that for configuration a little bit later. And finally, because it's this demonstration box, it can be a little bit difficult to see the unit right here, the actual AdVoTech2000 unit. I have a spare unit sitting over here that we'll be able to pick up and turn around and show you a little bit to give you an idea of the dimensions of the unit. Well, this is, as I mentioned before, this is the actual unit itself. I want to pick up this other unit here so you can get a good idea of what it looks like. Its physical dimensions. It's approximately 5 inches across, about 10 inches down, and 17 inches deep. Then on the back, you want to take them. There are a couple barrier strips there. We'll talk about those a little bit later. Reset button and a number of things, and we'll be plugging different peripheral devices into it. And then you may or may not be able to see on this unit, there's 6 lights in the front. We'll talk about those whenever I'm talking about the actual hardware in the machine. One of the things that this box has on it that our demonstration unit does not is a floppy disk drive here in the front. We'll talk about its use in a little bit. This is a unit itself. Actually, there are 6 lights in the front here that give us an indication of what the voice enunciator is doing. Its communication's good. We're scanning the PLC, calling in or calling out. We continuously test for errors. If there was a problem, either a software or hardware error or a power outage, there is a watchdog timer that we can't put in the machine as an option. It gives us a dry contact closure on the machine that we can either sound a bell or a whistle and let someone know that we do have a problem with the machine. 2 buttons on the front, acknowledge alarms and repeat acknowledge alarms. I'm going to press this repeat acknowledge.
No errors to report.
Get on this, that was a call in, so I'm recording this on my printer. We're going to talk about this printer in a few minutes, and then we're going to take it offline so it doesn't interrupt me. And then finally down here we have a switch, local or remote. Basically tells us whether we want to announce locally over a PA system, or I'm going to show this now so that I don't forget about it. The machine can be interfaced to both Motorola and Rytron radio repeaters, and then any of the functionality that you see right now that we have with the telephone coming out of the speaker set, or alternatively, whenever I'll be using the telephone to inquire into the machine, we'll be able to have with the handheld radio sets. So for geographically large plant areas, or alternatively high noise environments where we can't have a PA system, we can't hear a PA system, we'll be able to take the radio output into perhaps an OSHA headset and hear exactly what the process upset is without a PA system. Now the actual hardware in our hardware that we use in the machine, basically we use a 286 base processor and a 40 megabyte hard disk. The hard disk is used to store both the software and the digitized voice messages that we will be recording. And then there's a voice board that we've done a little bit of proprietary work on to speed it up. There are a number of peripherals that we can hang off of the machine. One is this is the video display, and this video display will bring up in large font any of my alarms and if they're digital in nature, the status condition, or alternatively their analog process value. The screen can handle up to 20 alarms, 10 per page. It will page back and forth. It will refresh every so many scans, a user-defined number of scans, and then we'll see the new analog process values come up. Second is that the video, this is an option. Standard with the machine is a DB25 parallel printer port. You might have heard that in the background previously. Any of the alarms that we have, there are 20-character description that we input with the configuration software will come up on the printer. Whenever there is an alarm, whenever there's an inquiry in the machine, an acknowledgement, or a clear, all of these will be time and date stamped for the particular process in question. Talk about the floppy diskette on the machine that we have outside of the demonstration case a little bit earlier. That floppy diskette drive is used for a extended history logging option. Basically, the information that we're getting on our printer will now be logged to the diskette, and we can take that off at our leisure and print it out and do a little bit of analysis. The floppy diskette is also used for our data logging option. The data logging option allows us to, because we'll talk about this in a minute, we scan or solicit the controlling device, or alternatively receive information from it. It's very easy for us to take that information and go ahead and log it to the diskette, so that people can then bring that diskette out and do a little bit of analysis in Lotus 123 or a different type of a statistical package of their choice. We mentioned that the watchdog timer, this watchdog timer option gives us the contact closure in the back. Also on the in terms of options we're not showing here, we do make this device at an optional 19-inch rack mount enclosure. We have also added an optional 24-volt DC power supply for people that wanted to drive the machine, would like to drive the machine that way. Now, I'd like to talk a little bit about how we actually attach to a PLC or a controller, or for that matter, different types of supervisory systems. A lot of the early work of the company was done in directly attaching to the PLC. It really is one of the strengths of the machine. Unlike some other devices out on the marketplace that do have voice associated with them, we can take this machine and interface directly with a PLC, RS-232. We'll talk about how we do that with the various PLC manufacturers, and monitor up to 999 points off of that PLC. So for the drivers that we currently have developed are Allen Bradley, pretty much across our product line. AdVoTech is a member of the Allen Bradley Pyramid Solutions Group, so we interface to the PLC 2, 3, and 5. For the PLC 5 and then also Data Highway Plus, we do require the 1784 KT card, which we ask the customer to drop ship to us here at the factory. We actually install in the machine, and then we'll hang as a node on the highway, and the AdVoTech2000 will be able to monitor any of the PLCs along the network by specifying the Data Highway Station node ID and then the appropriate register. So we'll talk about the concept and the concept of the machine and how we actually associate these voice messages to the points. For Modicon, we've have interfaced it to the 984 Modbus and Modbus Plus. Again, for Modbus Plus, we've asked the customers to drop ship us the SA85 card and then put it in the machine, much like we do the Allen Bradley KT card. The machine has also been interfaced to the Texas Instruments 500 series PLCs. GE, anything that is using or can use the CCM2 protocol, machine is AdVoTech2000, has also been interfaced to AdVoTech2000. And finally, it can be hardwired. So I can bring in the pairs of wires from my sensors to some I/O. Now the I/O that is required for that is extra, and if you're looking at a price sheet, it may or may not have that I/O on there. If you want to use the machine in with that method, you're best to call back here to AdVoTech to get a separate quotation for that I/O. Last but not least, we have a lot of interest in start developing some drivers that just will interface as RS-232 to basically any type of controlling device that can talk RS-232. Really with two methods. One is that for those people who have a supervisory system that will allow us to scan a data table and have the appropriate communications protocol in order to allow us to do that, we can go in and act as a scanner and bring information back, solicit, bring it back, and then do our work. Alternatively, there are two other methods of interfacing the machine RS-232 to these packages. One is to use the AdVoTech2000 and just send the individual strings, if you will, to say that this particular point is an alarm. Now I would like you to call out and do your work, and then whenever that alarm is over, I'm going to send you another point to tell you to turn it off. Second is that, and actually the preferred method for this type of interface is for the user to assemble something that we call our alarm database, and then send that block to us, and then we can act with all the functionality that the machine has that I can show you in a minute. It allows us to inquire to get all of our current analog process values, digital status conditions, whatever, without worrying about when that point was last updated. Again, as a scanner, I don't have this problem because I'm continuously going out and refreshing the data as fast as I can. I want to talk a little bit about the concept behind the AdVoTech2000, and it's in a sense very simple. Now I'm acting as a solicitor to the PLC. A couple things that the machine has to know, and things that we will talk about whenever we go ahead and configure the machine, is that I want to identify the register that I want to monitor. Got to be a digital point or an analog process value. Now I will go out and get that point and bring it back. Now with the configuration software for a digital point, you're going to instruct the AdVoTech2000 whether during normal operating conditions contacts are open or contacts are closed. And you will also specify a word, if you will, and this is a system generated word for that normal or abnormal condition. And these 26 words that we currently have in the machine are basically variations of the word on or off. And I challenge people, if they can think of another word to say on or off, another way to say on or off, we would go ahead and put those in the machine for you. We call this the digital status condition. The voice message that you'll hear on this machine when I set alarms off, you'll hear a pre-alarm message and then something we call the voice tag, and then we'll hear the digital status condition for my digital points. So if I'm interested in, say, a chemical transfer pump, my voice tag is going to be the chemical transfer pump is. And now the machine upon upset is going to generate the word not running or not operating or whatever. Now we've purposely set this demonstration unit up to use a female voice, what we call the higher level systems generated voices for the please stand by, an alarm has occurred. And then also at the end, the appended word at the end will also be the woman's voice, and then in the middle is me. And we'll at the end of towards the end of the presentation here, we'll be doing a configuration and actually changing some of the messages so you can see how they're changed. For the analog process values, what we're going to do is at the end of that tagline, we're going to append the analog process value. So if I'm interested in a temperature or say an RPM of a pump, my tagline might be the RPM of the pump now is. And then the machine is going to append at the end of that tagline 3,280 or whatever value it is. With the AdVoTech on these analog points, you're going to identify your trip point, whether you're tripping above or below a certain point, for that alarm to be triggered. Then finally, there's something we've added for our batch processors called Digitrip, and we're going to give an example of all of these alarms in a minute. But the Digitrip was a request from our batch processors. In a lot of instances, they're using the same equipment, but running different types of materials through that equipment. So what they had wanted to do was to reload their PLC and keep the analog trip values within the PLC. Now, whenever they have an alarm, they'll make a bit go high. So what we've added for our Digitrip, the concept behind that is that I detect the bit going high, and then I go in and read the analog. Value. So the message is constructed as an analog point with it appended that it's being tripped by a contact closure. So that's the concept behind the machine. I think maybe the best thing to do next is to set a few alarms off and do a little bit of inquiries into the machine. Now, I'm going to turn this printer off here. It'll be a little bit easier on us to hear some of the alarms. And I'll actually, if we get a close up on the front of the unit here. Set a couple of these alarms off. Okay, first one I'm going to do is I'm going to set off a few digital points and show how we actually use the buttons on the front of the machine. As I mentioned earlier, the two buttons, acknowledge alarms and repeat acknowledge alarms, local and remote. We have contact. There's a barrier strip on the rear of the machine that gives us dry contact closure access to these. So we can locate these anywhere we'd like around the plant, or alternatively take control of them with a PLC or another type of controlling device. So my first alarm, and again you're going to hear the please stand by, an alarm has occurred, and then my voice, the tagline that I pre-recorded, and then the system generated.
Please stand by. An alarm has occurred. The chemical transfer pump is not operating.
I'm going to acknowledge that alarm. Now, if I had not acknowledged it, and this alarm was set up this way, it would continue to repeat until it was acknowledged. Now, we can't set alarms up so that no acknowledgement is required, so the alarm will be spoken once, and then it will stop. Now, this alarm is not cleared, so when I hit my repeat acknowledge alarms, it's going to go ahead and say it again. And as I mentioned before, you heard three distinct segments there. The please stand by, an alarm has occurred. Now, that pre-message can be eliminated, or you can put your own pre-message in there, and then the user recorded voice, and then the one the system generated. Now, this alarm has not cleared, so when I hit my repeat acknowledge alarms button, we're going to hear it again.
The chemical transfer pump is not operating.
Okay, let's turn that one off. My screen, I don't know if we can see my screen. There's really no need to bring that up though, but no alarms are present now. Whenever the alarm was present, it shows up on my screen. Now, for this next alarm, I believe it's a tank level. I'm not going to acknowledge it, so we're going to let it repeat a couple times. Now, this interval that we're here between the alarm repeating can be set by the user from 1 to 100 seconds. I think we have the unit set up here between 10 and 20 seconds.
Please stand by. An alarm has occurred. The tank level is abnormal.
So we have a tank level that's abnormal as opposed to being low. Maybe we can use that as our point.
Please stand by. An alarm has occurred. The tank level is abnormal.
And that will keep repeating until we acknowledge it. Okay? Now my next digital is the batch instruction. I have a bit going high, and I chose what we call the no message option, so that nothing will be appended at the end of the tagline.
Please stand by. An alarm has occurred. Close valve 1.
It's close valve 1. So you can see this as an instruction. We can say that our operators close valve 1, limit switch goes, if this clears, and then we're going to tell them to close valve 2, etc. And that's the other thing is that as alarms clear, they come off, they will stop repeating, and they will also go off of the alarm table, so that when I do my repeat acknowledge alarms, we'll do here in a minute, I'll have no errors.
No errors to report.
I'm going to do 2 of the analogs right now, and then show you the Digitrip. And let's try this bottom one here first. I believe this is my compressor.
Please stand by. An alarm has occurred. The turbo compressor RPM is 21,375.
So the turbo compressor is 21,375. Now, you'll notice that that alarm did not repeat. We have set that alarm up so that no acknowledgement is required. So it is still on alarm, and we continuously update these analog process values. So now I'm going to dial it up just a wee little bit. We can see it changing on the screen here. It's going to move it up here to around 24,000, 23.8. And then go ahead and repeat it and get the updated analog value. You'll see later on as I call into the machine, one of the nice features about the machine is it can read analog values, and then remotely from a telephone or a radio, you can punch in different codes to get these analog process values. So I'm going to go ahead and repeat this.
The turbo compressor RPM is 23,847.
And I'm going to dial this one down here. Now my other, point is some boiling nitrogen, and it illustrates 2 other things that we've done with the analog points. One is that we can handle negative numbers, and second is that we can enunciate floating point down to 2 digits. So let's move our nitrogen temperature up.
Please stand by. An alarm has occurred. The nitrogen temperature in degrees Celsius is -97.96.
I'm going to acknowledge that alarm. So the nitrogen temperature is 97, and now we're moving back and forth here. Now I'm going to move this back down here, take it off of alarm. No errors.
No errors to report.
And finally, as my Digitrip, I have my Digitrip on this last digital point switch, but it reads that analog process value for the nitrogen, so I'm going to trip that one off.
Please stand by. An alarm has occurred. This is a digital trip alarm point. A digital contact has been closed. The temperature of the nitrogen in degrees Celsius is -361.67.
I'm going to acknowledge that. And now we'll turn that one off. I'd like to leave one of my alarms on for a minute here, because I'm going to show you how that we do remotely inquire into the machine for all my alarms that are present. So just turn this one on real quick.
Please stand by. An alarm has occurred. The chemical transfer pump is not operating.
Let me acknowledge that. Now remotely from the telephone, or alternatively using the keypad of the radio, we can inquire remotely into the annunciator. I think it's particularly with the radio in a large plant environment or high noise environment, for people to be able to figure out and find out exactly where a problem is, what it is, its process value, how to fix it from reasonably long distance off is tremendous productivity value for a lot of folks. The way that we inquire into the machine is that we tone the phone or the radio.
Enter your 3-digit request code.
Or ask for a 3-digit request code. We're going to ask for the
The turbo compressor RPM is 5,652. Enter your 3-digit request code.
Now I'm going to ask for my tank level.
The tank level is low. Enter your 3-digit request code.
Or alternatively, you can ask for everything that's on upset by pound, pound, pound.
Enter your 2-digit special function request code or wait for timeout.
And then I tone in 0, 1.
The chemical transfer pump is not operating. Enter your 2-digit special function request code or wait for timeout.
And as you recall, my chemical transfer pump is on the 1.
Enter your 3-digit request code.
Now remotely, when you're dialing in from the telephone, you'd be asked for a 5-digit access code before you'd be allowed to do any of that. And also, whenever the machine would be calling you, it would be asking for the 5-digit access code before it's going to give you any information. Whenever we get to the phone file maintenance on the configuration, we'll talk a little bit about how we work with phones, phones and pagers. At this point, there's really not anything else I'd like to talk about the way that the machine or the alarms work. I'd like to go into the configuration. Now, with the configuration, I'm going to be working on the PC here, and then of course it's going to be absolutely impossible for you to see what's on that PC screen, perhaps even if you were sitting right here in this room with me. So what we've done on the worksheets is attached not all the screens, but a select, what we feel are a select few screens that I'll be working on. I'm going to go over the highlights of the configuration, talking about some of the system parameters, how we set up the overview, if you will, alarm database maintenance, how I get my points in there and identify them. Then we're going to change some voices, talk about the phone file maintenance of the telephones and the pagers, and how we can go out to different types of PA systems. And then finally we'll start the machine back up and listen to some of our changes. So I was short now, and I'm going to plug my PC in that we use for configuration. And get that set up. Now with the configuration software, of course all the software for the AdVoTech2000 is on the system here itself. We provide you with emulation software to allow us to go RS-232 into our unit. And this is this cord, of course, in the back here. And I wait for an interrupt on the machine, and I'm going to go in and start to actually configure it. And as you can see from the sheets that you have attached, everything is menu driven. It was made that way so that it's easy. There are really 4 or 5 different steps to setting the machine up. The first is our system configuration options, and we have a number of different things on the first submenu. And we're going to talk about a few of those right now. My set PLC communication port is a screen that allows me to set up higher level parameters of how I communicate with the PLC. So I'll be asked for things like baud rate, stop bits, parity, things of that nature. The setup is can be more or less complicated depending on the manufacturer of the PLC. Whenever we're using a KT or SA85 card, some of those parameters have already been taken as protocols already been taken care of by the car, so we didn't have to set them up with our machine. We're going to play the greeting message here. The greeting message is what we hear whenever the AdVoTech2000 calls us on the telephone. And we're going to use that as our first opportunity to go ahead and change one of the voice messages. Now, we don't actually hear this when we set an alarm off, so we'll change another one also, but just as kind of as a warm-up, if you will. Show you how that we get voice messages into the machine. And it's very simple. Is I'm asked to record or play a message. I'm going to play what I have on there right now by toggling it down.
This is the AdVoTech2000 system calling.
So that's a female voice. So when I record over it, we'll be able to tell the difference. We'll say this is the AdVoTech2000 calling from Butler, Pennsylvania. In order to do that, I key up the next screen. I'm asked to strike a key here and start talking on the telephone, and then stop talking, indicate the machine I'm going to stop talking by tuning the telephone. So we hit the keyboard first. Good afternoon, this is the AdVoTech2000 calling from Butler, Pennsylvania. And now I'm going to play that.
Good afternoon, this is the AdVoTech2000 calling from Butler, Pennsylvania.
So all the voice messages, all the tags that we have in the machine right now were put in exactly that in that manner. The pre-alarm message is a please stand by, an alarm has occurred. The contact messages, in addition, there is for the machines that we set up to work with the PLC, there is one panic button contact closure that we give you in the back of the machine. So this contact message, whenever that closes, it can be evacuate the plane or whatever. Set system time and date, self-explanatory. Set snapshot repeat time for my data logging option. That's a global parameter for how often I want to log data. Set system parameters. We're going to take a close look at this because there's a lot of information on this screen. Maximum priority level is that we prioritize alarms by alarm type whenever we go through the alarm database maintenance. Maximum priority level is you can set the machine to just say perhaps alarms of 1 and 2 priority, and you can go all the way down to 10. So you can globally cut the system off, if you will, just give your high priority alarms. Message repeat time parameter, I have that set here at 6. That's that interval you hear between the machine talking. Auto remote parameter, that is, we set this up by alarm type, is that is how many times I'm going to call out a message locally before I start trying to reach somebody on the telephone. Now here the machine is not set in remote, it's set in local. But perhaps if this is a very critical alarm and we're afraid that we might have someone hurt on the site that's not responding to something that's critical, we want to, if the alarm has not been acknowledged, we want to try to reach someone on the telephone or page somebody. And then we have a number of rings, how many times I want the phone to ring, the phone zone delay period, and the pager support asterisk delay are similar from a standpoint is that it gives me a certain period of time between dialing the number and either dialing another number or taking some other type of action over a in-house phone PA system. A number of the PA systems are zoned so that if you have 3 or 4 different lines running, and say you have the AdVoTech2000 attached to a network of PLCs, say 4 PLCs, 1 for each line, you can just use one of our units to monitor all four PLCs. Now, whenever you have an upset condition, you can zone over your PA system through the phone that message. That's the phone, and then there's usually a delay period before you get into that that public address system through the phone. The pager support asterisk delay, because we didn't want to support everybody's pager in every part of the country, we found that there's usually some type of delay period between dialing a number and then there's a wait period before something else happens. If the tone happens or a 7 digits or a number of digits are keyed in for that person so they know where to call. Or alternatively, there's a wait period before some type of voice message is actually going over the pager. So that delay time there is set up globally for the system. The pager minutes before a retry is exactly that. Whenever we're working on remote or calling somebody out on a pager, we're going to we're going to page that person, and in most cases we're not going to be able to give them a voice message on that pager. It doesn't have a voice pager. And we're going to give them a certain amount of time to be able to call back into the machine. Now, if he doesn't do that, it's going to go ahead and try him again, or alternatively, if the machine, the way you set the machine up, it's going to move on to the next person. The way that we move on to the next person is our on-call maximum tries. It's how many times we're going to try somebody on an on-call list who's supposed to be getting this phone call or page before I move on to that next person. And these are all user selectable items. So we have included, we'll include this page with the videotape worksheets. The set term scan frequency, you may or may not have this on in your manual, depending on is that the video screen is updated so many scans we get on for the PLC. Verify system ready, will come back to it in setup. So we're back to our main menu. The real meat of the system is on our alarm database setup, and whenever we start out, the screen that I have here would be blank, but this is the point where we talked about the concept behind the machines. We're going to identify within the PLC where my points are that I want to monitor. So I'm just going to edit, we're going to edit one of these, and we'll show you. The first is an analog. These analog screens, I'm looking at my turbo compressor, and as much as we had thought it would be, is that we're going to identify our alarm tag number as something that means something to us, could really be anything. But next we're going to have one or two lines that's going to give me allow me to identify the memory location that I want to monitor. Now, when I'm on a network, say for like Modicon, my first line might be my slave address, and then the second line is going to be the memory location. For Allen Bradley, the first line might be the data highway station node ID, and then the second line memory location. Now, for my memory location, I'm using the PLC manufacturer's scheme of mnemonics to identify exactly where that point is. So we don't have to learn anything new. We just have to understand our own. We just have to understand our own equipment. I'm asked for a trip point to go down that screen, whether the alarm trigger, whether I want the alarm to trigger when that process value rises above or below the point. And then we allow you to put in the 0 and full scale and engineering units and the binary min and max. And we'll go ahead and automatically scale these. Scale the enunciation for you of the numbers. Filter value for my analog points, it's a digital smoothing algorithm that can go up to 70 and gives us a little bit of deadbanding for some noisy analog points, if that's what we have. And finally, scan priority can be from 1 to 10, gives an alarm priority of these alarms, how it's going to be announced. Now I'm going to page down here in our second screen. We won't show this, we won't have it with the Shield Digital because it'll be very similar, except that you won't have our negative numbers or floating point. And you can enable or disable these various features by alarm tag. In this case, in my compressor, negative numbers can be, do I want the machine to say negative numbers or not? Floating point, no, I don't want 2 digits. Data logging, I can select points individually, whether I want them logged or not to the data logger. I can by point automatically switch them to remote. I can determine whether I would like to, by point, I want this point acknowledged or not. And then my local announcement method is my phone zone or direct zone. The direct zone is going out over a PA system, which will be switch from zone to zone as opposed to a phone zone. Zone paging is the AdVoTech for right here. Then finally the phone groups. Now the phone groups will run from 1 to 8. This is a nice feature that we've added to the software. A lot of our customers had asked for this. We have 8 groups of 10 people that can be on call, and you identify by alarm type which group of people, which group of 10 you'd like to get called. So if you have an alarm that can be fixed by a group of electricians, or at least one electrician on the list, you would specify perhaps your phone group 1 is your group of electricians, and whenever I'm an upset and I'm calling out over the telephone remotely, I'm going to call this group of electricians. My second group might be a group of mechanical engineers. So if there's a mechanical upset, I'm going to call a group of mechanical engineers. The point being is that we're going to call the group of people that can fix the problem. We're going to go back and actually go into your next sheet there will be I'm going to go in and edit one of my digital points. And we're going to go into this transfer pump and edit it. And, we still have it high there. We'll hear it when we come back on. You see this transfer pump on your screen is that you'll see that it's very similar, but much reduced from the analog screen, because I just have to identify whether contacts are open or contacts are closed. And then one of these 26 different on-off words. Right now I have the pump can either be operating or not operating, and I'm going to change that to running and not running, so that whenever we hear it again, we'll know that we changed that. And we enter the appropriate number for what we want it to say. And 20 is not running. And then if I would page down here, I would get a very similar screen to the screen I got on the analog value. So I'm going to save this record and continue. And then last but not least, I'm going to, you can look at the Digitrip is really a combination of both of those screens. I'm identifying an analog point that I'm going to enunciate from, but I'm also identifying another point that I'm looking for my contacts open or closed, and then how that contacts open or contacts closed to be able to set that point on. We're not going to spend a lot of time on it, but it is available. So this is the first big step, if you will, of how I set the machine up. I'm identifying the points I want to monitor. The second step is to attach that voice tag message to the various points. We do that by same as we had gotten voice into the machine before. Now I'm going to play back this transfer pump.
The chemical transfer pump is.
And we're going to change that. Let's make that just the chemical transfer pump in Pittsburgh, Pennsylvania is. So we record it the same way as we've done before. The chemical transfer pump in Pittsburgh, Pennsylvania is.
The chemical transfer pump in Pittsburgh, Pennsylvania is.
So whenever we go back on scan, we're going to pick up this, we have this bit still high, we're going to pick our new message up there. Now, as you notice, there's enough room for 3 hours worth of speech on the hard disk, so we really don't have a real limit other than the space on the hard disk as to how long we want those messages to be. Typical messages from 6 to 8 seconds. Again, as I probably mentioned earlier, we have up to about 3 hours worth of speech available. The next step is we want to take a look at put people in the machine in order to be called out. We'll have one or two pages in your worksheet that will show this. We'll look at the standard call-out groups, and there's basically an entry screen for each of the people you want to put in, name, phone number, access code. The system user, yes or no, is a system user has a little more power over the machine, if you will, particularly for the data logger and for the extended history logging option. They're able to actually offload some of the data. And on this screen also I'm asked whether if I have a pager, and what type of digital tone or voice pager or none, and then yes or no for the various alarm groups for this person, specially 1 to 8 different types of alarm groups. So, now we'll come back to put it on this. And something we want to talk about, that I'd like to talk about briefly right now, is the phone zone paging. And for each of these phone zones, you'll notice on the machine I only have one acknowledge button. So that whenever we have 8 zones, that became a portion of what do we do. So we've, and we're not going to include this sheet within the worksheets, but what we do is we take, use the PLC as our, to help us acknowledge these different alarms, and basically write bits back and forth where the alarms have been acknowledged and not in that particular zone. And for those of you who are interested in this feature of the machine, you're encouraged to call and talk to some of our engineers as to exactly how that works in detail. And finally, I'm going to exit out of this. Now, the last thing before we go ahead and start the machine back up is that we're going to go ahead and edit my on-call groups. Now this is a group because you have a list of, now you've input names on your different groups. You have a, can select from this list the lucky people that are going to get the phone calls. And for anybody that has a priority less than 10, they're going to be called in that particular order from 1 to 10. And you can change this as you might. We'll finally go back to 1 to verify that my system is ready. And I've done everything right. If there were voice files missing, it would indicate at that point something else we've done wrong. It's going to go ahead and indicate at that point, which means that as far as the machine run knows right now, it's ready to go. Now, what could happen, of course, is that we may have typed in something wrong, particularly when we found in the early days that the people would try to monitor registers that didn't exist. So whenever we enter 9 here and press enter to start monitoring the system, if we were trying to scan something that didn't exist, we leave our configurator PC attached whenever we first do this, and it's going to come back and tell me that I've configured the AdVoTech2000 incorrectly, and I'm trying to monitor a certain point that doesn't exist. So I have to go back and change that. Also, if I was to have a communications break between the AdVoTech2000 and the PLC, it's going to go ahead and also call out a message. So I'm going to start scanning the system again by entering 9. And come back on scan. And as you recall, the first point that we did change, our chemical transfer pump. I'm going to set that off, and we'll hear the changes here.
Please stand by. An alarm has occurred. The chemical transfer pump in Pittsburgh, Pennsylvania is not running.
And I'm going to acknowledge it. So I changed 2 things on that. One, I made it a pump here in Pittsburgh, and now it's not running as opposed to not operating. Well, this is the conclusion of the demonstration of the AdVoTech2000. We also have a unit, the AdVoTech1500, which only monitors, very similar to this unit, but only monitors 64 points. We encourage you, particularly right after you've seen the demonstration, if you're doing your next day at work, you might want to give us a call to 2 things. One, any questions you might have had on the demonstration that we've given while they're fresh in your mind. Please give us a call and ask us. And if you'd like to give us a call and tell us what you thought about the tape in general, we welcome comments on that also. Now, while we have your attention, we've included a mailing label to be used in returning the tape. So if you would At this point, either use the tape to show, I guess, some of your additional friends, but if you're done, if you'd send it back to us, it would be very much appreciated. Thank you again, and have a good day.